In the last few decades, with the aging population, the prevalence of skeletal bone diseases has increased. In normal conditions, bone is continuously renewed by a coordinated process in which osteoclasts resorb the old bone and osteoblasts synthesize and mineralize new bone matrix. Imbalances in this process, increasing the activity of osteoclast and reducing the activity of osteoblast, produce a decreased bone mass and microarchitectural deterioration of bone tissue, leading to a skeletal bone disease named osteoporosis. The conventional treatment options of osteoporosis focus on inducing the activity of osteoblast, thus increasing bone formation, and suppression of osteoclast activity, preserving bone mass and increasing bone strength. Current pharmacological therapies are either partially effective or they present some limitations. Therefore, new alternatives are needed. In this respect, Professor María Vallet-Regí Research Group has used a different approach as a new potential and efficient treatment in osteoporosis. The Wnt beta-catenin signaling pathway regulates bone formation. Sclerostin is one of the main inhibitors of this pathway and is increased in osteoporosis. The reduction of sclerostin keeps active this pathway and therefore increases bone formation. For this reason, silencing SOST gene, which encodes sclerostin, using siRNAs could be an effective way of reducing sclerostin expression for potentially treating osteoporosis. Unfortunately, when siRNAs are injected, they are rapidly degraded in blood. Therefore, they need a nanocarrier able to protect them for their transport to the target tissue, the osteoporotic bone. Mesoporous silica nanoparticles could be the perfect vehicle to transport and protect these siRNAs. These nanoparticles measure around 100 nanometers and present a huge amount of pores. Moreover, their surface could be modified with different polymers and molecules to provide them with different capabilities. 1. Protecting and delivering siRNAs. 2. Guiding the nanoparticles to the osteoporotic bone. And 3. Make them invisible for the immune system. We can also take advantage of the high loading capacity of the nanoparticles to load the pores with a large amount of osteostatin, an osteogenic peptide which stimulates bone formation and reduces bone resorption. In this sense, we can address osteoporosis treatment by simultaneously increasing the formation of new bone and inhibiting bone resorption, reaching higher levels of efficacy. These nanoparticles have been tested in osteoporotic mice in order to evaluate their effect in the damaged bone. With this treatment, we have reached bone quality values similar to those in healthy bone and even superior to those with parathyroid hormone, the gold standard for osteoporosis treatment. Although there is still a long way to go, the research led by Professor Vallet-Regí is highly promising. The European Research Council Project Verdi aims the potential treatment of different bone pathologies through the development of versatile and polyvalent nanosystems.